So this is our thesis, right? The thesis here is the conventional application model is just broken, right? We're using a model that's 30 years old that was made when change was seldom. It was always central, right? And now we live in a world, and you essentially coded on top of a database, and you knew your target, right? Now we have diverse sources, diverse targets. I have to code in an environment where I might not know my source or target at runtime, and my workload might be variable as well. It might be adaptive, right? And so we have to allow for all of those things. So a model, I mean, if you think of it, the design, build, publish, revise loop is a model that's great for like furniture making when things are in a physical world. And this table has physical constraints. I model it, I design it, I push it out into the world. Its physical constraints aren't going to change when I publish it. But software doesn't have any of the constraints of the physical world. So why do we bind it prematurely? Why do we create this weird discontinuity, right? It's not natural, right? There's no, in our human world, there's no design time and run time. We just live, right? And we adapt, right? And so we are models of our parents. They give us genotypes, and then we take that and we implement those as phenotypes, right? And then express them uniquely. And then our models of the universe adapt to our circumstances, right? As I'm quickly adapting on my feet to make sure all those great people who preceded me that I don't run over them too much. I repeat what they've said. And I think a lot of the thinking at this meeting has been in this vein, right? I mean, we heard Roy Altman yesterday, people are networks, right? We heard just now Dennis, and Dennis was talking about how, activities are networks and models are networks, and we heard how events are networks from Flexicon. And so we heard all this network thinking, right? Of course, we're living in a network era, and that's our thesis, right? So we're looking at a world that is increasingly distributed and diverse. How do you do that, right? I mean, when we're looking at our flow chart, that's a beautiful abstraction, just like SOA is a beautiful abstraction. It looks pretty in the diagrams. At the real world, when I go and meet with CIOs and CTOs and VPs of IT, they're having a bear of a time doing governance, version control, right? Managing change, system-wide activities, right? Turning the spinning gyre, right? We've lost a lot of things, right? When we went distributed, right? And of course we're not going to put the genie back in the bottle. Everything's distributed network now. We've lost unifying principles, right? Of that the mainframe had. And when we talk about networks and some of the things that we've been talking about today about declarative and separating models from plans, et cetera, we really are starting to think functional again. And that's a very good sign for the future of technology. Because this is, I think, true, right? I mean, there's nobody who can argue the fact that application stacks don't help us. They just don't, right? And we went to SOA so we could avoid vendor application stacks, and now the vendors are coming back and saying, yeah, SOA is hard, buy my stack. What happened, right? I mean, the whole point, it was supposed to be beautiful and open, and it's not. And then, of course, we compound that with our hierarchies and our business silos, right? And those create more challenges. And it's not that those hierarchies don't really exist, and it's not that specialized needs don't really exist, right? Because they do. The difference is when you create fixed schemas and fixed models and you embed them throughout your enterprise, you destroy which is naturally a network of people, capabilities, devices, as Bosch had indicated, et cetera, right? So what we want to do is bind late, is what we want the world to do. So network architecture is transforming the world. Again, we've heard this time and time again here from many of the presenters over the last couple of days. I think obviously all you'd have to do is ask Roy Fielding if the world is a network, or Sir Tim Berners-Lee if the world is a network, or maybe Mark Zuckerberg, who went to my high school, if the world is a network, or maybe Sergey Brin, right, from Google. Is the world a network? Certainly the world is a network, right? We are a network, right? But our businesses can't operate that way, right? The ideal way we would work together is that we'd flexibly interoperate between people, capabilities, rules, and we would bind at runtime, right, within constraints. But those constraints would not be structures, right? When you bind in advance, when you go to design time and say, okay, I'm done. Design time, great. I got my inputs, and now the world is, somebody made a great point earlier. Take two people with look at something the same exact way. Answer is definitely not. So that means our interpretations of the world, the notion that we're model, they're abstractions by definition, which means we shouldn't bind them. But when we do that at design time, what we do is we bake in a context of the design, which is not mutable at runtime. What's the point of that? Except for the conditions allowed at design time, right? So it's not necessarily an ideal way to look at the world. So we're saying, actually, this is silly. We need a network application model for a networked world. It's overdue, right? And that's what we're bringing. So I wish we got to get to work on greenfield projects. The reality is that's seldom true is the world of greenfield. But I thought this was my big picture thinking, and I'd go here. So we separate models from implementation, and that notionally, as Dennis pointed out, gives you plans, right? So if you can separate your model from its implementation, you can issue a representation of a model to the users of the model, and that binds at runtime. It creates an affordance, right? In REST, we talk about affordances. It creates an affordance that implementation can be modified at its runtime by the user utilizing the model, simply, declaratively. If the user can change it, that means it can change their experience while they're going through it, right? It also means the system can personalize for it. We can automate that binding. We can personalize for that. And if personalization is too much automation, we can just do recommendations, predictive analytics, real-time predictive analytics inside running processes, millisecond speed, right? And we can also do global change, because I can change the local instance or I can change the model. And what's the difference between a developer and a user and a designer? They're just people. People in roles using a system that only exists in real time. I assure you that the computers we work on have no notion of design time and runtime, right? They just run, right? And so we all live in this real time. Let's let our applications live with us. And because if we want to get to the cloud and get the benefits of the cloud and the horizontal scalability, which it's all about, is the modern application layer is very much not horizontally scalable. It's horribly stateful, right? And so if we're going to actually achieve horizontal scalability, we need to achieve it at the app layer, because the app layers are the rate limiter. If your apps aren't horizontally scalable, your CPUs will not be optimized. And so this is what we do, right? And I try to make this, I avoided talks about, ethereal things like sparse matrix processing and, declarative programming models, et cetera. But, in short, we bind. It's loosely coupled stuff. It's a world of loosely coupled stuff. Think of the web, right? Most successful, stable, scalable network in human history. And it's just made out of stuff. Has anybody here ever broken the web? You haven't. How many people have worked in a business where their enterprise systems went down? At least once. Okay, great, thank you. So people love the web. How many people love their enterprise systems? All right, so we've got some real challenges here, and why don't we think about them in that way, in this network way that a lot of people were all coming together, looking at problems in the same kind of way. So now historically this has been very difficult, right? How do you mash up loosely coupled stuff on the fly for everybody, for every single instance of every single activity, all of the time? But we've been able to do that. So is what's behind our patents. But we're doing late binding. We have actually distributed software agents, and there's agents that actually can distribute themselves, super lightweight. They interpret models at runtime. They actually construct their own ontologies out of a loosely coupled distributed stateless space. They project schemas, right? Because a schema is just a fixed hierarchy. I mean, a flowchart, what is that? A flowchart is a set of fixed sequences, right? If we loosely coupled those tasks, we just have tasks, right? And then we could project them into a flowchart based on conditions. You could do the same thing with an ERD. You could do the same thing with anything. So we're constructing ontologies, projecting schemas, deriving the payload and UI to run on any device. And all the time, we're providing a full audit history and rollback. So in our domain, process is a set of loosely coupled sets, right? This is set theory, right? Is a set of loosely coupled tasks A running process is a series of asynchronous stateless tasks. Super scalable, super fast, 100% dynamic. So from any source to any target for any workload, because what's component middleware, right? I mean, the middleware vendors just like selling you, for every problem in middleware, they sell you another box of middleware, right? And so now my governance has to go through there too somehow, right? And my security has to cover that too now, right? So it's this game of reductionist modularity that is just not working. But what is a middleware component, right? It's just encapsulating transactional semantics and algorithms. Why don't we just let those algorithms be free, right? Mark Andreessen, Software's Eating the World, set those algorithms free. So what you really want is extensible agents that can actually do extensible programming at runtime, right? This is all for those PhD students here. It's all reflection, under specification, et cetera. So we start with unified storage of everything, right? Whether it's a device, a system, a database, business rules UI, structured data, unstructured data, whatever. We just, data and code, doesn't matter, right? Uniform treatment of data and code in a single searchable repository, right? So we can, now the organization can act as the network it really is. It's interconnected by links, we're familiar with that. It's then, and metadata, so we deal with it semantically, and change history, right? It's immutable, right? So this way we have full temporal history for perspective. So effectively a hyper-relational situation, right? The system agents can walk all relationships all of the time. It's friends of friends on steroids. All right, so our cute little system agents mash all this stuff up on demand. But this is really, I don't know if it's big enough for all of you to read, but this is what an anatomy of an interaction, right? Everything in the system, you can look at our system as being sort of an HTTP listener of some form, right? And we're responding to HTTP requests from human or system clients. It's calling up a software agent. Agent grabs the model that was requested. Agent goes out, evaluates rules, links, and metadata, resolves all the metadata references, does all predictive analytics. It can chase things out, right? We can run out of our system, grab another algorithm, do whatever we want. It's essentially creating what's called the behavioral pattern. And it gives us a targeted response every time. And it does this in a millisecond, right? And returning a custom payload for every single user and materializing to a database, right? We're not using gimmicks to create speed, to make up for latencies that are in the networks, right? We're doing this here, we're doing it real, it's got to be materialized. We need, context is perishable, so you need to capture current context all the time, and you need to use that context for your next execution, right? So that in our system, with a unified process architecture, every executing process can actually, in its execution, look at all the other executions of other currently running processes, or all past performances in its runtime, in its real time, right? And you can have cross-process governance, right? Because this is a schemaless space, right? There's no joins, right? So, and of course it works, I'm showing you the services, the APIs, whatever, and we inherit whatever latency comes through the network, as everybody else does too. But that's, for those who like SOA type diagrams, here is it notionally again, right? So we have modeling concepts, we could do analytics, we could do transactions, we could do automated scripts. We have one partner, they sent us a couple emails and a couple Excel spreadsheets in a single day. They said we had the best ETL. They were one of the largest integrators for SAP. And they said we have the best ETL tool on the market, and we built it in a day. Because we could do all of these things at once, right? We can apply analytics to automate scripts. We could do real-time validations of ETL data and data migration and data quality. We can actually push that into human processes, distribute the work down to a single field, trace that all the way back and forward, and of course be building notions of entities, et cetera. And at the same time, we have all these cross-cutting concerns being applied all the time. Security, governance. We version control everything, every interaction, every service that's run, every resource that's called. We have a full dependency relationship map of everything. And it's always accessible all the time. How much time do I have?
11 minutes.
All right, perfect. So I'm going to log in as Bill, and I should mention, so we have a great team behind us. Bill is my co-founder, co-inventor, chief system architect, a good friend, and a very smart guy, and I'm very pleased to have him. So this is not a singular activity. And I've also learned so much from this community. And as Nathaniel has noted, I've been working with the WFMC and Keith and others for many years, and which has been great. Okay, so the system starts, it's Java-based, so it just has the smallest bootstrap, and now we're in the system, right? So now I'm in as Bill. Bill has a notion of his inbox, and that's anything, his messages, his tasks, whatever it is. It opens up to his bio and search, and it's global search right off the bat. It's whatever, right? And so let's go create something. Let's go find something. So I want to find... All right, so I can find everything for cancer. I just want to find things that are related. This was automatically built out, by the way, so this is all projected at runtime. It found applicable collections that were related to this, and it built those menus out. It built the side menus out as well. All that's happening at runtime, real time. And so that I can look at things just related to proposals. You know, and I really just want things that are, maybe $200,000 or so. All right, so let's see. Oh, yeah, I can look at them. We call these baseball cards. So I can look at the details. Okay, that's interesting. Let me do this. I'm interested in the blood cancer one. Let's graph this object. Okay, that's for, I wanted to learn a little bit more about this. Okay, I'm going to drag our cheetahs out there. Let's see. I want to understand some relationships related to this program here. So I can go in here, I could change the focus. I can click on Bill Malik, and all of a sudden I've changed the focus of the graph. And now I'm saying, okay, that's interesting. And I want to see what Vamshi's doing. I'm just going to change the perspective to Vamshi. And what I'm really working my way through, and everything rolls over with it, details and stuff like that. But actually, I clicked on it wrong. I meant to right click. So let me go to Vamshi. I'm sorry, my vision is really poor. There we go. So now I open the record. Now I open the record, and I can see the notions of relationships are continued, right? Everything is an object in our world, and all objects have properties. They're all objects of types. It's a very flexible type system. This is not class-based inheritance, right? This is not hierarchical inheritance, right? This is all loosely coupled. In fact, like I said, it's loosely coupled information, right? Our repository is like a web server. It's just stuff with tags, stuff that's all, and our system agents, as part of their execution, are maintaining this environment as well. So we're doing things way beyond. I presented at the World Wide Web Conference, and Sir Tim Berners-Lee sat in on my session, and we're doing things way beyond what semantic web can deliver, right? Semantic web's great for discovery, but action, right? We got to discover things and execute against those things, right? I can look at anything. I can see its history, and I could drill into any event in its history. I can look at its details, what have you, right? And we're doing really crazy, rich forms. I mean, forms with hundreds of data elements, with relationships to multiple entities for projects run for 5-10 years that are subject to lots of variance, complex budgets, all sorts of things like that. So let's go into some of the fun things, the capabilities that we can have in a loosely coupled world. Well, we can go in here. Oh, the formatting is getting jammed up because of the size. My resolution's been compressed. So people can comment on things in line, right? This is all happening on the fly. People can make suggestions on things. We could see their suggestions. So we can actually be doing line item commenting and line item editing on the fly. All right, that's just one neat thing. Let's log out and log in as Archita, who's going to be our researcher. And Archita is another one of my business partners here. And just let me know when you need to give me the hook. I can just keep on going. There's a couple things I'd love to show if time allows, and you know what? I'm happy to show it later. So Archita's in here, but what I wanted to really do is show you that we can change things on the fly as well, right? Within constraints, but the constraints aren't structure, right? So Archita's looking at this, and she has this little notation there. She can change this, right? Your change will appear in the feature form immediately, will be subject to review. So she wants to change the label, my new label, And she wants to change the help message to see what I mean. And validation required, and she saves that. And she comes in here and goes, oh gosh, my value is not found in here. Let me go into this table. I need a value for a Silomar. Right? And save. So she's now just, requested those two things. And if I log out, Bill has in-flight change management requests, right? Bill can now look at them. It's giving him the change here. And should we allow this value? Sure. And do I apply it globally for that instance only? Reject, revert? I'll apply globally. And this process itself could be subject to any human workflow here as well. The development process itself, in other words, all of this stuff is infinitely networkable and chainable into value networks, right? We can take control over development, right? We can actually ensure quality. We can ensure document management. We can ensure data management. Just extending networks of processes for value networks, value chains, value networks, whichever term you prefer. So you did that one. It cleared the task. Let's go out here and say, no way. So it shows them the original version, shows them the requested change. I'm sorry, no. Right? Apply. Go back out as our cheetah. And I wanted to really show you some cool things in the modeling environment and in predictive analytics, but I think I'm chewing through too much time. But I'll 6 minutes, okay. Plenty of time. I might be able to pull it off. So in-flight change denied. Sorry. But hey, this happens. I'm of a school that believes that there are legitimate constraints in an enterprise, right? We have real-world regulations. We have real-world laws. We have HR laws. We have all sorts of things like that. And enterprise has interest. What is an enterprise if it has no constraints? What is this table if it has no constraints, right? We are networks with constraints. And so what we just don't want is constraints to be conflated with structures. So she acknowledges the decision. She's very sad about it. And of course, she could just keep on requesting it until they annoy Bill so much that. And all of this history is already preserved as well, too, right? So she's got this. That's great. So let's go in. She goes back into her record, and if the demo gods are with me, Silomar is right there. Ta-da! And let's go out. I want to do Q&A too. So Q&A, predictive analytics. Q&A, predictive analytics.
A little predictive analytics.
Okay. So I'm going to go in, Bill. So now I'm just another user, right? Why is the developer in design time somewhere else, right? Code gets tied in nodes. They're just tying things together with links and metadata. I go in. Bill's actually a developer, but everything's simulating in real time anyway, right? There is just real time. So I'm sorry, we hadn't prepared for being consolidated like this, but thank you. It just helped me find a bug. I got compressed by the video projector. It doesn't normally lay like that. So you can see it opened up to Bill's profile. He's just another human being. He's got a profile too, and Bill has some interests there. And Bill is actually developing a proposal, and he's going to click on it because it's just a task in his inbox. He's developing a proposal, and you can see he actually has some application configuration things going on there. And Bill is actually simulating it as he's building it. And let's see. Again, I'm getting a little here. Bill wants to go in and change a value. All right, so he's going to change it to that. So he actually picked something. It's an attribute that's going to be one part of a calculation on predictive analytics. And so it just ranked a whole bunch of stuff for him, right? And that's all being done on the fly. This is all predictive analytics. And if I go out and change it, and I believe I captured it. Oh, and I don't think I captured it. I think I didn't hit save. I didn't hit save. So the view you just saw there, 25%, 17%, you see those different numbers? Let's go out here. And again, this is just one property here, but if I go out now here, change, and I pick another value, and mathematical finish, save. All right, now He's changed the value. Predictive analytics, they're updated, 13.9%, right, at runtime. Let's go out and see how that got done. And again, I'm sorry, I'm getting a little scrunched here. And shoot. Oh, you just, what I really want to do is scroll a little bit to the left here. Well, so I'm sort of a bit ruined here, actually, in the sense that if I click to the side, it actually gives me the weighting, the predictive analytics, and it shows it to me. And if I click on it, it actually will take me to the policy. I can actually modify the policy right in place if I have those rights. And he could just play back and forth. As a developer, he's building and simulating in real time. No build, no compile, right? Now, it doesn't stop him. You know, all of our customers are enterprise customers. I mean, we're talking about customers with tens of thousands of named users, hundreds of thousands to millions of records, thousands of active records, people on our system every single day, running on commodity-level boxes, running in private cloud or cloud. And it's because the system's all logically multi-tenant. And I'll stop right there. And again, I'm happy to show some people offline if they'd like to see more.